Hey Thinksters, and welcome to this video where I want to show you real quick how to concatenate the string representations of a list of objects. Okay, so let's quickly get rid of my face here. So say you have the following object. You just create your own custom object, can be anything, and the object has an init variable, of course, so you initialize an instance of your object, and then the object or the class object also has the string representation. You define it with this string method, which returns like a string representation of the objects. And now you create a list of those objects and you want to print or concatenate the string representation of those objects. How do you do this? And by thinking about these kinds of problems, you basically become a better coder overall. You improve your skill level significantly and you will write more Pythonic code over time. So this is really an effective way to learn. Okay, so let's dive into the solutions. So I will maybe let's get rid of all the methods, or maybe I will just leave the methods here. Okay, so here we have the object representation with the constructor that defines like the data that is encapsulated by the class or by the objects of this class, and here we have one data value called val. And you pass this data value into your constructor. So you create an object by passing a data value into your object, and you use this object creation routine with the parenthesis on the object name, on the class name, to create a new instance. And we create 4 instances, like object 0, object 1, object 2, object 4. So they have values 0, 1, 2, 4, and stored within them. And now we want to have the string representation, which is like the string value of the value you store in the object. You want to concatenate those, and maybe let's first see what happens if you want to do this like the naive approach. Yeah, so say you want to just use the join method on your list of objects like this, then it will tell you, okay, so it expects a string instance, but it found an object instance which you created. Okay, so this doesn't work. The join method on the string expects that you pass a list of strings, not a list of objects, so a list of strings. So therefore, you need to convert all the objects in your list to a string value before you can join them together, okay? And so here you call, then the first method is to use the empty string as a delimiter between the values in your iterable. And as iterable, you use a list, for example, that you create with list comprehension. And what do you do in this list comprehension statement? You convert each element to a string using the default string representation of the object, or the defined string representation of the object for each element in your list. Okay, so you go over all these elements, call each element x, and then you convert this element to a string and you store this in a list. And then you pass this list into the join function. The join function simply concatenates all the strings that in the iterable that you pass. A list isn't iterable, so it simply concatenates all the values. And it uses the string on which you call the join method as the delimiter string. And if you don't want to have a delimiter, you obviously use the empty string. Okay, so if you do this, then this first method will, of course, return the string 0, 1, 2, 4, which is I can show you. So it will basically, all methods that we look at now will result in the exact same string. Okay, so we have 0, 1, 2, 4. All of them achieve the same, but they have different strengths and weaknesses. Okay, so this method is quite Pythonic. So I would say a good Python coder would already write this method. A great Python coder would see that it's not even necessary to have a list here. Yeah, so you can, because here you use list comprehension to create a list. But why should you create the list object in the first place? This only means that now you have in memory, you have like two lists. You have the first list that is a list of objects, and you have a second list that is a list of strings. So you duplicate your memory, you needed or required memory space by creating, a new list here. So this is not the most efficient way. It's only a detail, but if you have very large lists with thousands or tens or hundreds of thousands of objects, then it may even matter. So a great Python coder intuitively will choose the simplest way. So it will, and that is most concise and most efficient. Okay, so that therefore it's not needed to basically create this list. So you can also use a generator expression that is like the generalization of list comprehension that doesn't return a new list, but it returns a new iterable creates like that allows the join function to iterate over all values to join them together. Okay, so the join function requires an iterable and not a list. So all lists are iterables, but not all iterables are lists. So there are some iterables that are not lists, and these are more efficient than lists. So therefore, this method of not using the square bracket notation to create a new list, to use list comprehension, but to use a more generalized generator expression to do the same thing is more efficient. So this, I would say, is the most Pythonic way of using the join function on a list of objects to concatenate the string representation of the objects. Okay, so but then we also have, like, if you want to more customize the behavior a bit, you can also use this method. The only difference here is that in the expression part of your generator expression, you can really customize your output. So if you want to have another string representation, so say you don't like the implemented string representation, you want to have your own, then you can use your own like formula to create a string representation from an object. So this is just the only difference. So this allows you a bit more customization. Okay, so then also, like, a quite Pythonic way is to use functional programming. It's not that readable, and actually Guido van Rossum, the creator of Python, didn't like the map function, so he preferred generator expressions or list comprehension. There's a great article called "The Fate of MapReduce" in Python. You can check it out. It's really a good article, and but still, I mean, I think functional programming is fine. It's also readable for many coders. So this approach is also quite useful. So what do you do here? Yeah, you use the join function and the empty string, so nothing new here. But then you so what do you join? You join the result of the map function. So the map function returns a map object, which is an iterable. So you can iterate over the values of a map object. And what does it mean? So the map object takes two arguments. The first argument is a function, and the second argument is an iterable. And now the map function applies the first argument function, to each element in your iterable. Okay, so it transforms each object x to a string value, and creates a new iterable out of those string values. Okay, so we apply the same function to each element in your list, and by doing this, so basically we convert all objects into strings, and now we can join them together. So this also works beautifully. But now there's an even better. So this is, I would say, it's also fine. This is what a good coder could write, but a great coder will immediately see, okay, it's no need to use the lambda function here. Lambda function takes one argument and gives a return value after the colon, because the lambda function here, it takes an object and converts it into a string by using the string function. So then you will see immediately that it's basically the lambda function doesn't add anything new to the string function. So you can directly use a string function. Yeah, simply pass the name of the string function str without the parentheses, pass into the map function, so and then it will use the string function to convert each element in the list to a string value. So this is like, I would say, the most concise way of solving this problem even. So, and in this case I would sometimes even prefer it against the generator expression. So I like generator expressions more, but I can see why people argue that this is functional programming is really beautiful, and Python allows for it. Okay, and then the sixth method, I just added it for comprehensibility, because many coders coming from other programming languages like C++ or Java, they will use such an approach. Yeah, so they will create an empty string, then they will iterate over all list elements in a for loop, and simply use string concatenation. So they append one string element and at a time, so one string representation of the object x at a time to your string, and then you print the string. Okay, so it's like 4 lines of code, what you can also write in 1 line of code. So therefore, obviously, like an advanced coder, the most advanced Python coder will either use this functional programming or the generator expression with it, and in both cases he will use the join function. But of course, if you don't know the join function, if you don't know generator expression or functional programming in Python, because you come from Java where all these concepts don't exist, then you will use this method 6, this approach with many lines of code, and everybody will immediately see that you are a beginner in Python at least, but which is also fine. It's perfect. I mean, it's just about writing effective code. It's not so as soon as the code does what it is required to do, it is fine. And in many cases it's not even needed to optimize everything. Like pre-major optimization is the root of all evil, as Donald Knuth, one of the fathers of computer science, used to say. So you should not optimize if there's no need to optimize. So therefore you can also take this approach and it's not a problem. It will never harm you in any way, probably. With one exception, if you write really performance critical applications, then you should actually use these generator expression. I think generator expressions will be even more efficient than the map function, because here the map function also adds like a level of complexity. You also call another function. So Python calls a function and again a function, and then it takes the output. So each function call means that you need to add a stack of variables of this function call to your memory and to your RAM, and this loading thing has slight costs in performance. Okay, but anyways, I hope you liked the video. If you want to learn more about how to write very Pythonic code, then check out my book, Python One-Liners, and it consists of 60 one-liners, and I'll explain the one-liner to you, and it addresses different areas in computer science. So I wrote it as an introduction into computer science to bring you like from beginner or intermediate level to expert level in Python. So the book Python One-Liner appeared in 2020 with no starch press. You can either Google it or you check it out in the description below. Okay, thanks for watching this video and see you in the next video. Bye.